Tensors are awesome, and that is why we are going to learn about tensor operations. Now, tensors, you have a bunch of these numbers, but the question is, how do you perform functions on these tensors? PyTorch has a ton of math operations. Look at all these operations that we have. We've got angle, we've got arctan, we've got bitwise not, we've got ceiling, we've got a bunch of these different operations. And so today we're going to walk through a couple of these different operations and how we can use these operations to perform operations on our tensors, because that's really the core of PyTorch. So let's get started on some of the common operations that we might see during the day, and we'll learn together about different new features of operations that we can do. So let's start off by creating some variables, some tensors that we can work with so that we can have operations on them. So we can just start with like an x and a y. Let's say we got torch dot tensor. We'll do 1, 2, 3 for the first tensor. For the second tensor, we will have 4, 5, 6. Oh, I always forget to import torch. I do not know why I always forget to import torch. But this time, I'm going to import it. I'm going to x and my y. See x, see y. All right. Let's start doing some operations on these basic tensors. So let's find one that we like. Let's do something that's easy to start with. Maybe let's try, oh, subtract is right here. It looks like torch.subtract is an alias for torch.sub, little shorty. We've got an input, other, alpha, and an out. Let's look at alpha. Alpha is the multiplier for other. So this is some multiplier that we can multiply. So we've got out equals input minus alpha times other. So it looks like we can have quite a bit of control over how we're going to subtract our tensors. So let's try without the alpha parameter and just start with input and other, and then maybe we'll play with these. So let's say we're going to subtract, let's do y minus x. Y and x. We've got 3, 3, 3. Let's try torch.add. Okay, so we can add these tensors. What about torch.multiply? Okay, we multiplied them. What about divide? Nice. Does multiply have a shorter form? Is it mult? No, just mul. So we got 4, 8, 10 here. Interesting. So we've got all these different operations. Let's start playing with some of these parameters that we can do. So I've got this alpha here that's pretty interesting. It looks like we multiply alpha by other before we subtract it. So we've got our input, and then we subtract whatever our alpha parameter is. Alpha looks like it's just a number, so we probably just pass an integer there. And that will multiply times our other, and so we should probably get a smaller number if we're multiplying, if alpha is positive. So let's look at the subtract here. We'll specify alpha equals 2. Interesting. So we get a much smaller tensor values, let's say. But if our alpha was negative, then we probably get bigger tensor values. Yep. Interesting. Okay. So it looks like we also have this out parameter. The out parameter is the output tensor. So let's look. So I have used the out before, so it looks like you can you can store your output within an existing tensor. Um, that is pretty cool. So let's just call our output tensor Z. Maybe just like an empty tensor. Um, looks like we gotta have some data in there, just an empty list. We'll print out Z, so we just have an empty tensor. Let's see if we have an out of Z, and we print Z. Interesting. So it'll store it in Z. So this might save some time. I guess you could do maybe like Z equals torch.sub. I'm not sure why you would need to have the out. Maybe it has some sort of optimizations. So you'll have to let me know in the comments if you know why we have an out parameter there. I've never used that when I've used PyTorch, but it's definitely interesting. I'm sure that there's a reason that it's there, so if you do know, let me know in the comments. So let's see what else we can do. Let's explore some of these other ones. Let's try square. That one's interesting. Returns a new tensor with the square of the elements of the input. Okay, so it looks like if we had something like 4, 5, 6, we'd get like 16, 25, 36. Let's see what we get here. Yep, we do. Interesting. And let's see. Let's try another one. Maybe we'll try. What about pow? But it takes a power. Yep, it takes a power of each element and input with exponent, and returns a new tensor. Returns a tensor with the result. So the exponent can be a single float number. So it looks like it'll just take the power of each element. So let's try this out. Let's see if we can say like torch.pow of y, and maybe to the 2. We should get the same answer here. Maybe to the 3rd power. Interesting. Let's see if we can break this. Let's do like a huge number. Okay, so yep, we were able to break that. Okay, let's see what other operations we can do. Let's try. What is angle? I've never used angle before. Computes the element y's angle in radians of the given input tensor. Okay, so if we get something like this, that is quite a formula. Let's see. Let's see if we just pass in torch.angle what we get. So we have like torch.angle of y. Okay, interesting. We get all zeros. Let's copy this example and see what we can do. Okay, so we do get these. We do get these values. What if we got rid of those? So these j's are definitely having to do with something. I'm not sure what 1j is in Python and 2j. Are these imaginary numbers? I'm not quite sure. Let's look this up actually. What is j in Python? It is. It's an imaginary unit. Interesting. I have some experience with imaginary units in high school, but I haven't seen those in a while, so I really do not remember very much at all about them. So right now I'm not gonna try and relearn them, but maybe one day I will. those are interesting. Let's pick one more before we wrap up for the day. Let's see. We've got. Let's try a bitwise operator. And we'll try bitwise and. So it looks like it returns a tensor of the bitwise and between the first tensor and the second tensor for each unit. Torch.bitwise and of x and y. Okay, so let's see our x and y, just so that we can kind of visualize what's going on here. So we've got our x and our y. So we say 1 and 4. We're 2 and 5. We're 3 and 6. Not sure how we got 0, 0, 2. Let's read a little bit more into this. Computes the bitwise and of input and other. The input must be of integral or Boolean types. For Boole tensors, it computes the logic and. Okay, so it looks like we got -1, -2, and 3, and then 1, 0, 3. And our output would be 1, 0, 3. Let's copy this example and try it out. Okay, so what if we played with this one? Maybe a negative number. What if that was positive? It's the same. 1 and 1, I know is going to be 1. So we've got 2 and 0, so we know that's going to be false, definitely. -3 and 3, we know that's going to be 1. So I guess that just means that we can't have, we always need to make sure that this number and this number is non-zero. What if we try -3 and -3? We get -3. Yep, and let's see if we tried 4. Okay, so we get this larger number here. What if we tried like -5? What do we get? We get -7. Interesting. If you know what we got -7, let me know in the comments. I'm not quite sure. I know the basics of bitwise, but I definitely need to brush up on that. But this was definitely interesting, kind of walking through some of the different tensor operations that we can do. As you know, we can do any operation basically that you can think of. And if you haven't thought about it, then also let me know in the comments of operations that Torch should have. But to be honest with you, if you can think of an operation that Torch doesn't have right now that you need that's relatively common, then you are very, very smart. So that's all I have for today. I hope everyone has a great day. That's it.